Hey guys, today we'll be doing Leetcode problem 322 coin change, and this is a medium DP problem which I've been working on the whole problem set, and it's been a little bit difficult, but this one I kind of pre-read it before. It doesn't seem too bad, at least the brute force solution, but obviously we don't want brute force. But yeah, let's get straight into it. So
You are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return false. You may assume that you have an infinite number of each coin.
So we can use an infinite amount of each coin. So that's like saying we can use two fives. 5 plus 5 plus 1 does equal 11. So my guess is we're going to start from the back of the array and work our way up, or work our way towards the front, so that we have in that way we use the least amount of coins, right? So instead of, doing 11 ones, we do two fives and one one. But that seems a little bit too easy, so we'll see. I'm not exactly sure how you would break this up into sub-problems, right? Because the whole theme of DP is breaking up this bigger problem into sub-problems. And this is a medium, so I'm not really sure. But I guess let's just code this up and let's see what problems are. Also, I forgot to mention, so let's say we gotta get our base cases down. So, okay, and now let's talk about the base cases. So let's say our coins is just an array of 2, but our amount that we want to reach is 3. And this is not possible, right? Because there's no combinations of 2s. You can only do 2 plus 2, which would be 4. You always overshoot 3. And in this situation, you'd return false. So this is just a base case we have to take care of. And I'm thinking that there's no like easy way, like there's no quote unquote hard coded way to do this. But all I can really think of right now is just, I guess, working our way back through the array. I guess let's like run through this. Let's run through how we would do this normally, like as a human, not in code. So once again, let's just use the same example. So our coins was 1, 2, and 5, and our amount we're trying to reach is 11, right? So we start, I think instead of adding, we can just subtract, right? So I worded that wrong. Instead of trying to like start at 0 and adding up to 11, I think we can just subtract, which I think would be a little bit easier. We can have a for loop where we start from the back, obviously, and we keep subtracting from this until we get either a negative number or we reach 0, which then we can like return our answer. And obviously we'll have a variable for every time we subtract a coin to count up each one. So right now we're at 2. So once we get to 1, say we subtract 5 again, our number is -1, less than 0. So then we can just increment in our for loop, right? And then try the same thing for 2. Oh no, obviously 1 minus 1, 0, and here we can return true. But maybe this obviously would work, but I'm just not sure about the time constraints, right? Like this seems pretty brute force, and I'm wondering if there is a better solution. Let's get back to where we got to our base case where we could either increment our for loop or return true, or return our amount that we got. So we were at 1 after subtracting 5, right? So right now we're at, let me erase this. So right now we're at 1, 2, 5. Right now we're at 2, right? So we know that this is always gonna return false. And let's say, for example, we had more coins inside of here, right? 1, 2, 3, 5, right? We know this here is always gonna, where we're gonna skip over these, right? But how can we implement that? I'm thinking that I want to like just pass over this. I don't want to have to, loop through each one. I want to find a way to just skip this part entirely. We're gonna have two variables, obviously the amount we're gonna want to return. So let's just set this to 0. Res equals 0, and then a for loop that we want to iterate backwards. For I in range length of coins -1. I think if we start, let me look at something real quick. Coins at I minus amount is greater than 0, or not a for loop. I need a while loop, right? Because we want to iterate. We want to keep subtracting the same coin from amount until it reaches a negative integer. So let's do a while loop instead. Or actually put the while loop inside. I'm stupid. So while coins at I minus amount is greater than 0. Or let's just do if not amount, right? Because this was just like this will just check the Boolean value of this to see if it's 0. So if it's 0, that's when we want to return true. If not amount, return res. And here we want to increment res plus equals 1 for each coin. Okay, let me think through this. So for I in range, this will iterate backwards. If not amount, return res. While coins at I, oh shit. While coins at I minus amount is greater than 0, we want to increment our coins counter, and then we want to update the amount. So I think we're missing one more base case where obviously if we would need to return false, and we return false. I think we can just return false by the end, right? Because if this never gets triggered here, then the only other option is to return false. I'm pretty sure. Because this here should take care of the logic where, like, say for example, we have an amount 3 and coins 2, right? So for this our coins at I will be 2, right? While coins at I minus amount is greater than 0, which it's not, then we'll iterate to this will pass to the next index, but there isn't, right? Where our coins, let me call them, coins is equal to just 2, right? Just 2, and our amount was equal to 3. This will just end the loop and return false. So I think this does take care of every scenario like this, maybe not just one. It should take care of every scenario just like this. But let's run and hope for the best. The range function is start, what is it? Start, stop, end. But when you reverse it, your start is really gonna be your end. Oh shit. Start, end, step. I'm fucking crazy. So when you reverse this, you want your start to actually be your end, so you just flip-flop these. Let me do that. So length of coins -1. Our end, we want to end at before -1 because it's non-inclusive, I hope. Okay. So this is never getting triggered then. Oh my let me write out the logic for this code. Let's just run through like a simulation for this. Okay, I think I got it. So I was really missing this equal sign here, because this here, say our amount left was 1 and our coins was 1. It was just, this was returning false, so it was never updating our result variable. So I think this should do the trick. Okay, there we go. That's that test case, but let's submit and see. Okay, so it's not sorted. That's unfortunate. So I was wrong about the array being sorted. I guess it was just that one. We're gonna have to do this another way then. I'm not sure if we should sort the array. I don't think that would really be optimal. Maybe there's like a sorting algorithm that we could use. We know for sure that we want to start with the biggest coin and work our way backwards, right? But if the array isn't sorted, I'm not exactly sure how we're gonna do that. There probably is some sorting algorithm that would be used here, but I'm just not sure. Like, I don't think we would use like a heap or anything, because I feel like that would add too much time to this. But we definitely have to sort, because it would not be optimal. Okay, so let's take the test case they just gave us that we just failed. 2, 5, 10, and 1. Right. We for sure have to sort this. Like, there's no way we could solve this optimally without sorting this this array, because to reach the desired or the expected result, we need to start with the biggest number, which is 10, right? But it's in the middle of the array. Like, it's not at the end or anything. Like, this isn't in decreasing or increasing order. So I'm not sure. Maybe a heap would work on this. I'm not sure though. I think it's n log n to actually heapify it, but then popping is just log n, but peaking I think is constant. But we don't want to peak, we actually want to pop. I'm not gonna lie to you, I'm gonna tap out and I'm gonna start this shit either tomorrow or later today, because I'm hungry as fuck. Okay, so I did end up looking at the solution and I was very off. But yeah, it's just seems like a bottom up approach, and there are actually sub problems when you solve it with like DFS and you use backtracking and stuff. But yeah, I was trying to go for like, I thought there was I guess a super optimal solution with like linear time complexity, but it seems like it's still kind of worse. So the lookup time in an array and a hash map is like the same thing. Like, what are we losing by using a hash map? And we're going to be looping through this basically. So for each, like, this is going to be, I guess, our cache, right? And we're going to be saving the pre-computed amounts for the smaller subproblems of starting like at 0, 1, 2 until we add up to our final amount that is what we're looking for basically. If A minus C, yeah, I thought this is how you did it. Yo, like, what the fuck? This shit is hard as shit, bro. So it's DP of 4. Okay, I see now. So what he's doing here is, like, you found your coin, right? You have your coin, DP of C. This is the 1, right? But you have to, now you're using your, I don't know, your cached coins, where you have the coin that you found here. This is a possible this passes this test. So you're doing, for example, 7 minus your coin value, and it's leaving you with this. And this is your pre-computed value that you stored in here that you did before this in each iteration. But I'm confused how, let's say you have a coin, say you have a solution where you're reusing multiple coins, but this only goes over one coin one time, which I'm not sure about. This, I would never have fucking gotten this, bro. So let's run through this one more time. Let me just, I guess, what would be the word? Like blurting or some shit? See if I understand this correctly. So on the first line here, we're just caching. We are using a cache to store our pre-computed values, right? And we're setting them to a default of some, I guess, arbitrary number, just like the max value. I don't think it matters what. You just want to make sure this is greater than your actual amount value. And obviously we set dp of 0 to 0 for, then you loop over every amount value. So from, say example, amount was 7, from 0 to 7. And then for each coin, then you want to check if it's a possible solution. If it is, then you set it to the minimum. You set min, either take what it is now. So if it was the default value, this will, on the first iteration, this will always set it to our new one, right? And it's 1, which is your coin right now, plus the remainder, right? So let's say this was, what, 7 minus 4? Oh shit. Let's say this was 7 minus 4, which is, 4 is our I right now. 7 minus 4 would be equal to 3. This will check dp of 3, which we computed before this, right? We're doing 4 right now, but before this we did 3, and for 3 we went through the same process. So this should have, like, say, let's say for example this was 2, right? dp of 3 was 2. This would be your coin right now, 4 plus 2. And then at the end we return the value we computed last, which is dp of amount, and we only return this if it's not equal to the default value, basically. So the whole point of this default value is we always know whether, like, this value is going to be the same across the board, so we always know if we even found a solution, right? If we didn't find a solution, like, let's say, for example, we couldn't compute this, it was impossible, like we had an odd number for our amount and two, or our coin was even, that would never be possible, right? And this logic here takes care of that, because it wouldn't pass this test, or I'm not exactly sure, but all right, so that was fun, I guess. So some things I want to look into now that he mentioned in here, and I see is like a theme going on, is obviously memoization. Like there, genuinely, like, fucking, it's been like four past problems using that. Obviously caching, which is I think the same thing. What else? He mentioned recurrence relation. I definitely should look into that. Seems like something important. And I don't know. I mean, this solution is very simple. It's just, building off of these sub problems. But I think this will be good for now to look into. The fuck is that sound? But yeah. I will see you guys next week. I'm gonna try to make this like a weekly thing to just hold myself accountable, obviously, and actually do some Leetcode, but also I think it's good to be able to talk through my thinking and stuff. See y'all next week.